Today we're going to be looking at parent functions and transformations. All right, here are the state standards that are in this lesson today. And to be successful, you need to be able to identify the function family to which a function belongs. You need to be able to graph transformations of functions, and you need to be able to explain how translations, reflections, stretches, and shrinks affect graphs of functions. All right, your parent functions are very important to know. Here's pictures of your parent function. You've got a constant function. So this is a horizontal line, y equals 1, or in function notation, f of x equals 1. And you need to be able to tell your domain and range as well. A linear function, y equals x, that would have a slope of 1 and a y-intercept of 0. So again, function notation is f of x equals x. An absolute value is a V-shaped graph. So we've got y equals the absolute value of x, or f of x equals x. Again, all of these, you also need to know your domain and range. Quadratic function is a parabola or a U-shaped graph, and it's f of x equals x squared. So make sure you're aware, absolute value is a V-shape, quadratic is a U-shaped graph. All right, there's a few vocab that you need to put in your notes. Make sure you learn these, study them, review them, and hopefully it will help you with the upcoming lessons as well. All right, so a parent function is the most basic function in a family of functions. A transformation changes the size, shape, position, and orientation of a graph. A translation is a transformation that shifts a graph horizontally and or vertically, but does not change its size, shape, or orientation. A reflection is a transformation that flips a graph over a line called the line of reflection. Often that'll be the x-axis or the y-axis or something like that. When the factor is greater than 1, the transformation is a vertical stretch. So a vertical stretch means you've got a factor greater than 1 for your a value. When the factor is greater than 0 but less than 1, meaning it's a fraction, it's a vertical shrink. So pause the video if you need to. Take time to make sure you've got those in your notes. And when you're ready, you can move on. All right, number 1, example 1 says identifying a function family. All right, so the first thing it says to identify the function family to which f belongs. So this is f of x right here. 2 times the absolute value of x plus 1. And then it says compare the graph of f to the graph of its parent function. All right, so identify the family function. This is an absolute value. We know that because it's a V-shaped graph. So we know that it's an absolute value. And if you want to compare it to the parent function, let's see what we can write. All right, so we know it's an absolute value. Remember, the absolute value parent function is f of x equals the absolute value of x. All right, so if we want to compare it, we can say that the new function, let's call the parent function g of x since the new function is f of x. Let's call this one g of x. It's just the name of the function, so we can call it whatever we want. All right, so we're going to say this one is the parent function. G of x is the parent function. F of x is the transformation. So what happens? So the graph is shifted up and it's narrower. It's narrower because of this 2 that's multiplied by the absolute value of x. And it's shifted up 1 unit because of the plus 1 there. All right, we also can compare the domain and range. For the absolute value, we know the domain is all real numbers. Okay, so this one, the domain is all reals. That can also be written as negative infinity to infinity. So either or. And the range of the parent function is all y's greater than or equal to 0. But the transformation f of x you can see it's been shifted up 1. So the domain is still going to be all real numbers. That's an infinity sign there if you can't read my handwriting. And the range is all y's greater than or equal to positive 1. And you can see that by looking at the graph right here where it's been shifted up 1. So again, when it says identify the family of functions, identify the parent function, and then compare the graph using things that you can see based on the equation. All right, there's 2 graphs right here. This is a self-assessment, meaning I want you to pause the video and I want you to try these on your own. So you're going to do the exact same thing. Identify the family of function to which it belongs, and then compare the graph of G to the graph of its parent function. All right, hopefully you paused the video and took a minute to look at these and see if you could figure these out on your own. That's the best way to know if you're learning the material or not. All right, so the first one you can tell it's a line. So this one is linear. The parent function is just f of x equals x. And so we know that this one, g of x, has been moved up 2 units because of the plus 2. The domain is all reals. The range is all reals. So but for both the parent function and the transformation. So the domain and range did not change here. For this graph, you can see it's a parabola. It's a U-shaped graph. So this one is a quadratic based on the shape. The parent function would be f of x equals x squared. Every quadratic function has a largest degree of x squared. And the graph is wider, g of x, the graph is wider because it has the 1/4. Remember, if the number is between 0 and 1, the graph is going to be wider, and it's moved to the right 3. Again, the domain is all real numbers for both the parent function and the transformation. When it has arrows going to the left and right, that means arrows mean it's going to continue on forever. And the range for the parent function, because it would be at the origin, would be all y's greater than or equal to 0. Since this one was shifted to the right 3, it's still all y's greater than or equal to 0. So both of these had a transformation, but it did not change the domain and range of the new function. All right, moving on to example 2, graphing and describing translations. Example 2 says graph g of x equals x minus 4 and its parent function. Then describe the transformation. All right, so remember the parent function is f of x equals x, so it just has a slope of 1 and it goes through the origin. So this would be the graph of the parent function. All right, it also says remember the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. So you can see that this one has a slope of 1 and a y-intercept of negative 4. So if I take this function here and I simply move it down 4 units, so down 1, 2, 3, 4, it still has a slope of 1, but now it has a y-intercept of negative 4. All right, so we can say that this is the parent function, f of x equals x, and this is g of x. All right, it says, then describe the transformation. So what do you see? Well, it moved down 4 units. So now they have different y-intercepts. The slopes are the same. They still have a slope of 1. Both of them have a slope of 1. So you can say f of x has a slope of 1, and g of x has a slope of 1 as well. All right, what else do you notice? The y-intercepts. So the y-intercept for f of x is 0, and the y-intercept for g of x is negative 4. All right, so if you talk about the domain and range, they both have a domain and range of all real numbers. And you can tell this because, again, your domain comes from your x values, left and right. So this one goes left forever and right forever. So does this one. So both of them have a domain of all real numbers, which is written as negative infinity to positive infinity. And the range, likewise, your range goes for your y values, so up and down, it is going up and down forever as well. So also negative infinity to positive infinity. You should have studied domain and range in depth in Algebra 1, so hopefully this is just review when we talk about domain and range. All right, graphing and describing reflections. Example 3, graph p of x equals negative x squared and its parent function. So you can see again, I've already graphed its parent function. F of x equals x squared is a parabola that goes through 0, 0, negative 1, 1, and 1, 1. So 3 points, you can sketch that curve. Then describe the transformation. All right, so it says remember a function p of x equals negative x squared is written in function notation where p of x is another name for y. So again, that's just repeating what I said on the first slide here. So if we want to graph p of x equals negative x squared, we know that's going to be a reflection across the x-axis. So let's graph this one in red. All right. It's going to be a reflection, so that means it's going to have still the same y-intercept, and this time it's going to go through all right, so it still goes through the origin. This time it's going to go through 1, negative 1, and negative 1, negative 1. All right, so what can you tell? How can you describe the transformation? It's a reflection across the x-axis. All right, now how do you graph this if you don't know that that's what it is? All right, how would you graph this function here? Well, remember, you can always choose x values and plug it in to find your y values. And y equals p of x in this case. All right, so if I choose negative 1, 0, and 1, and I plug those numbers into this function here, negative 1 squared is 1, and then that would be a negative here. So negative 1, negative 1. 0 squared is 0 times anything is 0, and then 1 squared is 1 times negative 1 is negative 1. So you can see those 3 points here that I graphed here. If you're not sure that that's just a reflection across the x-axis, you can always choose x values, plug it into the function to get your y values and graph those points. Just make sure that you have positive and negative. You want to have a point, at least one point on both sides of the vertex. All right, self-assessment. I want you to pause the video and take a few minutes to graph each function and its parent function, then describe the transformation. So A, B, and C, you've got 3 functions here. Pause the video, take a few minutes to do that. All right, I don't have much time left, so I'm going to quickly go through these. Number A, or letter A, is a linear function. The black one is the parent function for all 3 of these, and the red one is the transformation. So you can see that this one got shifted up 3, and the domain and range would still be the same. The only difference would be they would have a different y-intercept. They still have the same slope, but different y-intercept. All right, B part, the black one again is the parent function, and you can see the red one is h of x, the transformation, so it's been shifted to the right. 2 units has the same domain and range. The only difference is it has a different x-intercept or a different vertex. And C is an absolute value graph that's been reflected across the x-axis. So absolute value is a v-shaped graph. The parent function is f of x equals absolute value of x, and n of x equals negative absolute value of x. So that's why it's reflected across the x upside down. Would have the same domain and range and the same vertex.